What's going on, everybody? Welcome back to another video. I'm doing this one really late at night, so if I'm seem like I'm whispering, then I probably am, since it's like 2 o'clock in the morning. And so I just sat to myself thinking, oh, what's a good way that I could just spend the rest of my early morning? Why don't I just make a video on Kerberoasting? So that's what we're gonna do today. But before we even get into Kerberoasting and attacking the authentication protocol, Kerberos, what is Kerberos? How does it actually work? Alright, so I'm gonna try and explain Kerberos as basic as possible without going too in-depth into anything else. So in front of me, I got a diagram. We have a user's workstation, a domain controller, also known as a KDC, a key distribution center. Domain controllers are a KDC in an Active Directory environment, and then you have an application server. So before I even get into any technical terms, let me just throw you this analogy that basically explains this, for those that learn easier that way. Let's say you are a 10-year-old kid and you're going to a birthday party. You're on your way to a birthday party and you're almost there. You're just across the street from there, and from across the street you can take a look at all the games and everything else, and everyone's having fun. But then you look at this one specific game that you want to play, and it's like these kids that are just busy throwing water balloons at each other, right? So you're over here. This is you. This is the KDC. Think of it as the front gate in order for you to get in there. And this is the game. So you want to be able to access this game, but before you access the game, you have to actually walk through the gate. So now here you are walking up to the gate, and you talk to the person. You're like, hey, so how can I actually get inside there so I can play that game? And the person that's at the gate is like, well, your name has to be here on the list. And so you give it your name, and then they check the list, and they're like, huh, okay, so your name is on the list. And now they're going to give you this band that actually allows you to be able to do things now. Alright, so now we're inside of the party, and now we want to actually be able to play a game, right? We looked at that water balloon game. We really want to play that water balloon game for some reason. Now you're inside the party, you're asking around for people like, oh, how can I go in and play that game? What am I supposed to do next? And then someone tells you, oh, that's easy. You just take your band that you have around your wrist and go to the table over there, up to the KDC, go up to the table over there and ask them that you want to get a little ticket that you'll use to be able to access specific games. So now you start walking over towards that table that you got directed to, and you go over to the KDC, and so we present our TGT. So we present our band that's around our wrist that basically identifies who I am, my name, my address, everything else. And then I ask the person at the desk, hey, so can I get a TGS? Can I get a ticket so that I can be able to play that water balloon game? And so now the person here is at the desk, they look at your TGT, they're like, okay, so your name is Adam Matthews. Okay, Adam Matthews. Alright, we're gonna use this, just scan here. And so let's say they have like this little machine, right? It's like a barcode reader. And then they're gonna use that to generate that ticket. And so now you scan it, right? Beep. And now out of the printer is that TGS, or that ticket that you can try to use to access the game that you want to play. So that whole process of receiving that ticket will be right here at number 4. So we went up, we asked for a ticket, we received one back based off of our TGT, our wristband. Now the tricky part here is, what the person at the desk didn't tell you is that anyone can get a ticket. All you need is the TGT, and you walk up to the front desk and you just ask for a ticket to try and access something. But what they didn't tell you is they aren't the ones that check to see if you're even allowed to play certain things. So here we are now, finally, we have our TGT, right, our red wristband from the person at the table, from the KDC, and they created this ticket based off of our TGT, so based off of our information that was on our wristband to generate that ticket. So now we're back here. So now we're walking up. Imagine those are steps of walking up to the game, the water balloon game, but there's a door here, and in front of that door is a security guard, and security guard is asking you, ticket please. And so what they're doing is they're asking for that TGS, that ticket that you got from the person at the front desk. And so you present that to them, and what they're going to do is they're going to look at that TGS based off of your TGT, because it was generated from your TGT, from your wristband when you got it scanned. And so they're going to look at their own list, and they're going to try and compare the two. So they're going to be like, okay, so from my list that I have here, these are the allowed people that can walk through this door. And if your name isn't on there, then you can't come in. So they're gonna look at your TGS. They're gonna keep looking. Okay, so this person has permissions to do this. They can do that. Oh, I see. You're also on the list. You can access this room, this game. You can access this service because you have permissions from this TGS, from this ticket. This ticket's allowing you permissions to access this service. So all the authentication is done when you attempt to try and connect to a service. The domain controller or the person at the front desk doesn't really care what you're going to do with this ticket. They don't check whether you have permissions to even request anything to try and access a specific service or play a certain game, so to speak. All that is handled when you walk up to the front door or the front desk of whatever you're trying to access, right? To say whether it's a file share, a web service, or whatever else. The actual application itself is what does the checking to see whether or not you have privileges to do what you're trying to do. And in this case, since we did have our name on that list, we were able to access that game that we wanted. So when a machine first connects to Active Directory, before it even is able to connect, the domain controller has to have a copy of their password hash in order for them to connect to the domain. So it's basically going to send its hash. The domain controller is going to look in here. It's going to be like, oh, okay, I know who you are. It's going to send you that TGT or that ticket granting ticket. Once you have that ticket granting ticket, that's basically saying, all right, cool, you're now connected to Active Directory. You're part of the domain. And also with that TGT, the TGT is what's used in order for us to get tickets so that we can try to access other services. So for example, let's say right here is a file service. We're going to use our TGT, so we're going to present our TGT to get a TGS. A TGS is what we'll actually be using to connect to the service. So every time you have a TGT is always used to just request a TGS, a service ticket. That's why it's called TGS, ticket granting service. So that service ticket is what we actually use to connect to a service. But also with that TGS, all your permissions and everything relies solely on what you have as that TGT. So for example, let's say right here is a file service, and this TGT was requested and created for a user called Mike. Okay, Mike has decent permissions, but he doesn't have permissions to be able to access this. So this service is a file service. So he goes and he requests a TGS, a ticket, to access that service, because you can't access a service directly with just using a TGT. You always need a TGS to do that. So he requests a TGS, and then he goes over here to the application server. It looks at his TGS and is like, Mike doesn't have permissions to be able to access this server, and then it gets blocked, denied, and you won't be able to access that. But on the other hand, let's say we had a user named John. John went, he requested a TGT, he has a TGT, and he requested a TGS to be able to access this server here. And so now he presents that in front of the server to try and access it. It looks and it says, oh, okay, so based off of this TGS and looking at my list, all the boxes are checked, he has permissions, and he can go ahead and access the service. In the real world, this would look something like this. The user, they connected, they used their the password hash that's on the KDC, it matched, they got their TGT, and now they're trying to open up Skype. So once the user opens up Skype, it actually causes their workstation to look up the service principal name for the user's Exchange server. The service principal name, or an SPN, is a unique identifier for a service instance. Active Directory, domain services, and Windows provide support for service principal names, which are key components of the Kerberoasting mechanism through which a client authenticates as a service. SPNs are used to provide mutual authentication between a client application and some kind of service. An SPN provides identification between the service type, so let's say something like HTTP, SQL, CIFS for file stuff, and the server actually running that specific service to enable the client to confirm that this is the true identity of this service. So here we have a diagram of the syntax of an SPN. So it has four parts. We have the service class at the start of it, HTTP, LDAP, then the second part will be the computer name and the port. So we see the computer name here, the host that's running this specific service, this MySQL service, the domain, and then the port that it's running off of, and then the service name. And also here we have a second example for service principal name. We see machine 1, we have the KDC. I need access to host workstation 01, so we can assume here that he's trying to do some type of PowerShell remoting into a workstation 1. So this server would be the unique SPN. So this SPN wouldn't be the exact same value as another one, because this uniquely identifies that this service is running on this specific machine on this port. And then he gets that. Can I get a TGS for the service ticket? Here's my TGT to provide that to prove that it's me. He says, you got it. One service ticket coming right up. I don't even care if you're allowed to access that service. Not my job, boss. So going back to the machine trying to access the Exchange server because it's opened up Skype, this would be the SPN of that Exchange server because it wants to access that specific Exchange server. Alright, so once the user opens up Skype, the workstation will look up the server's principal name for the user's Exchange server. Once that server is actually found through its SPN, its specific SPN, the computer communicates to the DC again and presents the user's TGT as well as the SPN for the resource. So the SPN will be for the TGS so that it can connect to that exact specific service. The DC replies with the TGS Kerberoast service ticket. And now that the user machine has the TGS, it goes ahead and presents it to the Exchange server for access. And if they have the right permissions and everything seems okay, then they're able to access Skype. Here I am on my DC, and what I'm going to do now is show you a TGT. So I'm just go to open up PowerShell, we type in klist, and then we see that we have one cache ticket. So we take a look, we see we have client administrator, that's us, we type a who am I, or you can already just see inside the line here in the path, we see we have eCorp administrative, and then we see server, and then we have this account called KRB-TGT. The KRB-TGT account in Active Directory is a local default account that acts as a service account for the KDC, Key Distribution Center, that is used to encrypt and sign all Kerberoast tickets for the domain. A service account is essentially a specially crafted user account that an application uses to interact with the operating system. Services use the service accounts to log on and make changes to the operating system or configuration. So for example, let's say that we have a SQL service that's running, right? It has its own specific SPN, and in order to interact with that, you don't want to just use a regular user account. You want to use a specialized crafted account or service account that is specifically made to interact with that service. So it'll only be given permissions to interact with that service. So let's say, we got a SQL and we got a SQL service running, and now with that SQL service, we'll have a SQL service service account that will be specially crafted to interact with that service. So looking at the rest of this TGT, we see the encryption type, ticket flags, we have the start, end time, and renew time. So the thing with tickets is that they eventually do expire. So this is also something to put in mind whenever you get onto a machine, a Windows system on an Active Directory environment, and you go ahead and try and take a ticket from a machine. You only have a limited amount of time before that ticket eventually expires and you wouldn't be able to use it anymore. So that's also something to keep in mind. We see session key, cache flags, and KDC called. Right, now that all that theory is finally out of the way, Kerberoasting. Kerberoasting is a very popular attack vector aimed against service accounts in Active Directory. The problem is when these service accounts have weak passwords and when there is weak Kerberoast RC4 encryption used for encrypting their passwords. Kerberoasting takes advantage of how service accounts leverage Kerberoast authentication with service principal names. Attackers possessing a valid Kerberoast ticket granting ticket (TGT) can request one or more Kerberoast ticket granting service tickets (TGS) for any user with an SPN from a domain controller. So again, any user that has a TGT, so if I have a TGT, I can request as many TGS service tickets for any user account that has an SPN assigned to it. So the attack is basically broken up into these 5 parts. 1. Identify user accounts with SPNs, so accounts that have SPNs assigned to them. 2. Request service tickets for these accounts. 3. Extract tickets and hash values associated with them. 4. Brute force these hashes offline. And 5. Gain access to a service account using the cracked password. When it comes to discovering Kerberoastable accounts, there are many different tools out there for you to use at your disposal, but for this demo, I'll be using Bloodhound to discover possible Kerberoastable accounts and get user SPNs from Impacket to grab their TGS for us to crack offline. If you're unfamiliar with Bloodhound, Bloodhound is basically a tool used to map out attack vectors from an Active Directory environment. It grabs all the objects such as users, groups, computers, ACL information, and links them all together like a spider web to basically rid the headache of going through endless amounts of data, attempting to map out what is related to what, putting it all in a graph for ease of use. Here's the GitHub repository for Bloodhound in case anyone is interested. I'll leave a link to it down below. Now, usually when it comes to grabbing information and data from machines, Bloodhound uses either the .exe executable or the .ps1. So that means that it requires you to be on a Windows system machine. But what many people don't know is that there is also someone created it, Foxit created a Bloodhound Python ingester. This means instead of having to be on a Windows machine to run a collector, you can run it straight from your Linux terminal. And you'll basically get nearly the same amount of information from Shophound, from the original collector created by the creators of Bloodhound, but just a few things missing, such as you can see here, see features below supported collection methods, mainly GPO based methods are missing, and Kerberoasting authentication support is not yet complete. So you get like the main stuff, but you're going to be missing out on a few things. If we scroll down, we could see how to install it and what it requires. You can install the ingester via pip by clone repository. Bloodhound.py requires Impacket, LDAP 3, and DNS Python to function. Use the ingester. At a minimum, you will need credentials of the domain you're logging into. You will need to specify so-and-so. You have DNS setup, and automatically, by default, Bloodhound.py will query LDAP and the individual computers of the domain to enumerate users, computers, groups, trusts, sessions, and local admins. If you want to restrict collections, specify -- collection methods parameter, which supports the following options similar to Shophound. And so over here is everything that it collects. So to get started, first I'm assuming that you already have Bloodhound installed. So you want to start up the Neo4j server and type in Bloodhound. And then log in. And now you should see something like this. And so at the moment we just want to leave it, so we can just minimize it. And now we actually want to go to the Bloodhound Python ingester. So I have that in OPT, cd into bloodhound.py, and just see the files here. Let's do Python bloodhound.py-h to see how to use it. Got collection method, username, HTTP password, Kerberoast, DNS domain. Alright, so let's do Bloodhound-u. Let's use the user Amos. -p screen 10 -de corp .local -ns 192.168.131.129, which is the domain controller, and then -c for collection method, and then just type all. And let that run, and it's done. So now we see these extra domains.json, groups.json, users.json, computers, etc. So what we want to do now is actually go back into Bloodhound, the GUI, and then go to upload data. And so now we want to upload those JSON files. So upload the users, upload computers, upload domains, upload groups. I believe that is it. Wait for this to finish. I was like, alright, clear to finish. Exit, refresh. Now if we go over here and we click more info, you should now see that these have been populated. The amount of users, the groups, etc. Relationships, ACLs. So now if we go into analysis, and then we do find all domain admins, it'll basically give us an output of all the domain admins within the domain. So what we want to do now is actually click this again, and then go to list all Kerberoastable accounts. And if we check, we have the KRBDGT and we have the SQL service. So we just click the SQL service, see some info, display name, object ID, admin count. True. Okay, so we know this is an admin user. We see the service principal name that was given to it. Distinguished name, the domain, ecorp local, SQL service. But if we go over to here, reachable high value targets says 10. So if we click this, we see that it actually changes. So now we see everything that this user is able to access. So we see they're a member of the domain admins group. They're also a member of enterprise admins group. They're also a member of administrators, a member of group policy creators. A cool thing also is if you right click the tags in the middle. Also, you can see one here like for right DACL. You can click help, and then it actually gives you some information. So generally, the user SQL service at ecorp local is a member of the group administrators at ecorp.local. Groups in Active Directory grant their members any privileges the group itself has. If a group has rights to another principal, users/computers in the group as well as other groups inside the group inherit those permissions. So it gives you a little general description of what member of means. It'll also give you some ways to abuse it. Obviously, this here isn't anything to abuse, but if you were to go over to something like generic all that does have an abuse factor, then it'll give you, what command to run in Mimikatz to be able to abuse this ACL permission. So we see that this SQL service user is actually a domain admin, and they're also a Kerberoastable user account, service account. So that means that if we're able to access this service account, then we'll automatically be able to access a domain admin, and therefore from there we'll be able to dump the ntds.dit file from the domain controller. So let's go ahead and do that now. Let's get in our terminal. So now what we want to do is use get user SPNs from Impacket. So get user SPNs, and what this will do is basically query TGSs for each of those Kerberoastable user accounts. So any user account that has an SPN set for it, we'll get an TGS from it. So request ecorp.local ecorp.local / let's use the user amos, hit enter, and then we want to give her the password, so ice cream 10, and then we get a hash back from the SQL service. See the name, the service principal name that was set on it, member of, password last set, last log on. And so what we want to do now is actually take this hash and then save it into a file. So let's just call it hash, paste it, and then use something like John to attempt to crack it. So John hash, and then use our rocku.txt. You can see that it tells us the type, Kerberos 5 TGS, and we were able to get the password, my password 123 with a symbol at the end. So we were successfully able to exploit this service account via Kerberoasting because it had a very weak password. But we also see that this service account has domain admins, right? So now let's try and attempt to dump that ntds.dit file from the domain controller. Secrets dump. Let's change this to SQL service. Hit enter. Paste in that password. And we were able to dump the hashes. Just as simple as that. All it requires for you to do is just to have access to either a TGT or just access to any domain user credentials. Alright, on to mitigation techniques for this specific type of attack. If possible, use group managed service accounts which have random complex passwords greater than 100 characters at times and are managed automatically by Active Directory. Ensure all service accounts, user accounts with service principal names have long complex passwords greater than 25 characters, preferably 30 or more. This makes cracking these passwords far more difficult than you saw just now. Service accounts with elevated AD permissions, such as this one that had domain admin rights, ensuring that they have long complex passwords. And also ensure that all passwords for your service accounts are always changed on a regular. That's about it for this video. If you liked it, hit that thumbs up, subscribe for more content, and I'll catch you in the next one.